Hello there, my name's Fernando, and I'm a developer advocate here at GitLab. And today I'm going to go over a little tutorial on how to use GitLab Advanced SAST Security Analyzer, along with GitLab Duo's Explain This Vulnerability in order to address a vulnerability. And I'll go through some triage flows, and I'll show you how to use these things to not only figure out how a vulnerability affects your system, but we'll also go through exploitation information that's provided, and we'll exploit a vulnerability in an application, and then we'll use the results in order to remediate the vulnerability. But before that, let me just explain to you what GitLab Advanced SAST is. So it's a static application security testing analyzer designed to discover vulnerabilities by performing cross-function or cross-file taint analysis. So what it does is it goes through your static source code and it tries to find patterns which are vulnerable. And the difference between the regular SAST and the GitLab Advanced SAST that we provide is that you can actually see these things across multiple functions and multiple files. So the way that that works is with every vulnerability, or with most vulnerabilities anyways, you're going to have a code flow which is going to go over the steps from the source to the sink. So the source being where the data is input, where the vulnerable data is input, like user can manipulate the source and where it comes in, and then the sink, which is where it's actually used and where a vulnerability where it can be exploited. And it'll go and it'll provide the relevant files and the relevant code snippets. So it's pretty much tracing everywhere that a vulnerability goes through. And the features that it includes that you see here is the source detection. So the user input that can be tweaked by a malicious entity. So if you're doing, let's say, a SQL injection, and you're allowing in a particular function, you're allowing a user to input particular data, like let's say their name, to then run a query, then here, this is the source, because a user can add, an escape character or something, and then they can manipulate the query based off of what they input in order to exploit and, grab more data, leak a bunch of data, drop tables, whatever malicious action that they can try to do that will be, they'll provide success to the malicious actor. Then there's the sink detection that actually shows the sensitive function call. So this is what's actually running the SQL injection for that example. And this is where the arguments should not be controlled by the user, but are. So you see kind of in this example here that you're grabbing input data, and the input data is actually being used down here in the OS system command. So we generate a command from all that data that the user inputs, and then we're running a command. So meaning that a user can remove all directories, or they can run a command that does something really malicious and deletes everything on the system, or injects some malicious code into the system to monitor it, or adds a backdoor. There could be endless possibilities to how to exploit it. So it includes all that data that's very useful for SQL injections, cross-site scripting, different things that span across multiple files. So that's the cross-function and cross-file analysis. And then it also has sanitizer detection, so you can avoid false positives by showing areas that, are vulnerable, but you are applying a sanitizer, making it non-vulnerable because you're removing a lot of the escape characters that are possible. And these are the supported languages so far for Advanced SAST. So it'll overwrite whatever the SAST scanner is once you enable it by just including this variable and having the SAST template running. Then you can enable it by implementing GitLab Advanced SAST to true. And then what we see here is we have the GitLab Advanced SAST. It supports these languages, and then the languages that it doesn't support, then it'll pick up the default scanner for that. So for example, if we enable it for .NET, then the semgrep scanner won't run and only the Advanced SAST will run. But since it's not implemented for Apex, PMD runs. Since it's not implemented for C, then semgrep runs. So we still cover all the languages, and we don't have duplicates of vulnerabilities. We just have particular vulnerabilities that Advanced SAST runs, and it'll override the other scanners that it supports. And we're working on supporting more and more languages as new releases come out. But we still cover a bunch of different languages for SAST. And you can see different frameworks that are covered and what they're covered by in the docs. Now, when these scanners are run on the main branch, they populate the vulnerability report, which has the vulnerability page, which gives you a bunch of information on how to resolve it, which we're going to go over. But it also includes this Duo explain the vulnerability that helps you summarize it, gives you an idea of how it can be exploited and how to mitigate or remediate it. So you have all that available to you, and it sends it to the Anthropic Claude 3 Haiku LLM, and then it sends the code over to that, and then that processes the response that shows you how to exploit and remediate it. And then if you want to learn about privacy, where the data is shared, you can explore the documentation and make an assessment based off of that. But in order for all this to work, you need a license of GitLab Ultimate, which there is a free trial for, and then you need a license for GitLab Duo, which there's also a free trial for in order to use both these features. So GitLab Advanced SAST requires GitLab Ultimate, which you can see here, requirements. You need GitLab 17.4, and you need an Ultimate subscription. So that's what's required there. And then for this vulnerability page, you also need to be on Ultimate, but you need to have the GitLab Duo subscription as well. So you can see that here. And you can try these things for free. I'll link the pricing page and the free trial pages in the description, and you can go from there. But now let's dive into the tutorial. And for this tutorial, I'm going to use this Juice Shop application. And what you can do is you can clone it into your own space and then work on it from there, the space that you've applied the trial to. So I'll link this in the description as well, but it's gitlab.com/gitlab-da, which is the developer advocacy group. And then there's tutorials, security and governance, OWASP, and then Juice Shop. So you can go ahead and clone this in your own space where you have the Ultimate license, and then you can follow through on this particular tutorial. So the first thing that we see here is that in the GitLab CI YAML, we have the SAST template, and we also have the variable to enable GitLab Advanced SAST. There's a bunch of other stuff here, but all you really need is just the test stage, the GitLab Advanced SAST to be enabled, and the SAST job. And automatically SAST will auto-detect the languages, and with this variable, it'll automatically run GitLab Advanced SAST. So, and let's put up a screenshot here. So this is what it looks like, and this is exactly how you need to implement it. And then you can just copy and paste the code from here in the project, then you can remove all that just so you can just test out GitLab Advanced SAST. Just make sure to include the test stage as well. And then what this will do is it'll generate this pipeline. And what it'll do is it'll generate a pipeline, and let's go to the most recent run one. So pipelines. And then you can see here, in the test stage, we ran GitLab Advanced SAST. There's build, and then there's a bunch of custom pipeline stuff, but then there's the Advanced SAST. And then here you can see the job output and what's done. So we don't really need to look at that. We're not debugging. Note that you can also configure this how you would any GitLab job. So the syntax is the same for any job, and you can also do debug and look at different rules. So I'll put a link to the description, but pretty much you follow along with the GitLab job syntax, and also go to the SAST documentation page. So you can know how to configure these, add before scripts, add rules, add different things of when to run it, how to run it, what to include, what to exclude. So all this is applied to any type of job, even if it's jobs that are included by GitLab in different templates. So once this job runs and completes, what it'll do is it will populate the vulnerability report, which pretty much shows all the vulnerabilities detected within the main branch, this being the master branch. And this is configurable. You can change what you want the main branch to be, but I have it set for the master branch in this project. And then I can sort by, the severity. I can say critical, let's say, and I can say tool. If I have other scanners, which other scanners did run here, I can just sort by the GitLab Advanced SAST scanner. and then go from here and you see all the vulnerabilities are detected. I can change the statuses, pretty much for when triaging, I can go through all the different statuses and go from there. And this will give me all the vulnerabilities found in that main branch. So what I'm going to do is, now I'm going to show you what is provided with the flow. So what I'm going to do is, there was one that I wanted to show in particularly with the code flow, which is this basket. And what this shows you is the scanner provided all this data on the vulnerability. So it's an improper neutralization of special elements and data query logic. That's the title, and this is the description. So there's a potential NoSQL injection vulnerability in your JavaScript application that uses MongoDB, and the vulnerability arises when user-controlled data from sources like HTTP requests is passed directly to a MongoDB find_one function. In the detected code pattern, user-controlled data is being used as an input in the find_one function, allowing executing arbitrary JavaScript code on the server. If this data contains malicious code or expressions, an attacker could potentially execute arbitrary operations on the database, leading to data manipulation, exfiltration, or even complete system compromise. So at the worst case, complete system compromise, mid case data manipulation, or best case scenario, they'll just be able to grab data, which is not good at all. This is critical in nature. So the impact can be severe, and gives you a little bit more information on that. And then it tells you to mitigate this, use a library like Mongo Sanitize to avoid passing user input directly into the function. So here's an example of what it looks like with the Sanitize included. And then we see the actual line of code that's vulnerable, and we can go to the actual location. And we can see that the find_one, this is the vulnerable line of code where malicious data can be passed into the ID. And we can also look at the CWE here. So there's a CWE, and we want to learn more about it, how it affects the system. We can become a more security educated engineer by following these things and seeing how it affects our system. And we can be well versed in these types of vulnerabilities. So, and a CWE is a common weakness enumeration. So this is part of Mitre, and it includes all the publicly released vulnerability data and a lot of data on how it happens and similar examples and how it affects your system. So I urge you to look at these resources if you want to become more educated in security. There's also training from our partners. So in this case, Secure Code Warrior and Secure Flag. You can go to their different training pages, and there's some free training that you can follow that goes in here. You can continue as a guest. And then you can learn in your particular language how to perform these exploits. So this will be JavaScript, let's say. So you click on that, and then I can enter game mode, and I can start playing around with this vulnerability and exploring, doing tournaments, gamifying it. So depends how you learn. You can use these resources to make you more security focused and go from there. The code flow is also what I wanted to get to. So remember we talked about source, where the user passes in data, and then sync, where the data is actually executed, the untrusted data is executed, and something risky is happening there. So here we can see with the actual code snippet that we grab the actual ID from a request, meaning that it is possible for the user to manipulate that request and pass in something different for when it's used here in the basket.find_one, meaning that I can add some possibly malicious queries or some type of escape characters, so it's not validated, into this ID, and I can perform some malicious functions. At any case, I can probably just use this to grab other people's items, and I'll go over that. So there is some finding where I need to exploit and what I need to do. I know it's in this particular basket, so I know that in the logic of the basket, there's something malicious that can be done to inject something into the ID and then do something malicious with the basket. So I know the part of code that I need to examine. And then I can also use this explain with AI. I had run it before, but what it does is it'll send it to the LLM, the Anthropic LLM model, and then it provides you information on, exactly how it works, how to exploit it, and then what I need to do to resolve it. So this is what I need to do. I need to sanitize it with Mongo Sanitize, and then this is how I can exploit it by adding some possible malicious data as the ID to the request and going from there. So it gives me data on how to exploit it. So I get data from here, I get data from here, and I can use all this data together along with the resources to then figure out exactly what to do. So I already know I need to be able to manipulate that ID in the basket, and I can play around with it. And I'm using a well-known example here with the juice shop. So now what we're gonna do is we're gonna dive into actually building this application, and then we're gonna go ahead and try to exploit it. So what I'm gonna do is I am gonna go to juice shop and clone this so we can exploit it. So let's get that. It's got on my desktop and git clone. And let's use my work key. And now we're cloning this juice shop application, and we're gonna go ahead and perform the exploit on it. So what I'm gonna do is I'm gonna build this as the Docker image or the container image. And then what I'm going to do is I'm going to build it with Podman actually, because I do use Podman instead of Docker, but you can use Docker if that's your container solution or container storage. And also GitLab has built-in containers. If you want to, you can write a function to build it in GitLab and it'll push it to GitLab's built-in container registry. But for the sake of this example, I'm just going to run it locally. And the way that I do that is I just run Podman build. And I'm going to tag it with juice shop. And this is I'll just tag it by the branch name and then dot. And then this will take a bit. So I'll catch you in a few minutes. All right, so there we go. The building the container finished successfully. And here in Podman, we can see our container images for juice shop. And what I'm going to do is I'm going to go ahead and run this application. So in order to do that, I run podman run and then --rm -p. Let's run on the local host 0.0.1. And it's going to be on port 3000. And then let's choose next. Okay, so got it. I accidentally put juice. It's juice shop master. All right, and then let's go from there. All right, so now it's running on port 3000. So now let's open up an incognito window. So let's go to File, New Private Window, and then I'm gonna go ahead and navigate to port 3000. All right, and here we have the juice shop application. Now, this is provided by OWASP to show how to exploit websites and common vulnerabilities, and you can learn more about that here. So I'll provide this link in the description, and you can learn more about OWASP Juice Shop and how you can use it to exploit different vulnerabilities and pretty much learn about this. So it's a really great tool, really great resource. And you can even go here and try to perform the exploits yourself and learn how they're performed. And there's kind of preparations for hacking, challenges, etc. So I'm going to go over through this, and you can actually follow along if you want to exploit this yourself. This is the basket example, so you can actually do this, and this is the exploit that we're going to perform, which is viewing someone else's basket. And that's going to be done here within the local application that we have here running. So the first thing that I need to do is I need to create an account to log in. So just a standard user account. So what I'm going to do is I am not yet a customer, and I'm going to go ahead and create Fern at fern.com. And the password is going to be password1. Password1. Show password advice. See, it has this advice, but I don't think it actually uses it. Security question. What is your favorite pet? Let's say the Tanuki. That's the name of my favorite pet, the GitLab Tanuki, which I don't think has a name, but we'll just keep it at that. And then I've successfully created an account, fern@fern.com, password1. And then we're going to go ahead and log in. And now we have access. We see the basket here. And now we're going to go ahead and try to exploit this. So what I'm going to do is I am going to use the developer tools provided by the Chrome browser, or in this case, the Brave browser, or any Chromium browser. And you can see that we have session storage. So we can see the network, everything that happens on the network. Like if I click on this, what's going on. And, just play around with the tool. If you know the tool familiar, you can examine different things. But what I am doing is I'm going to go into the actual application itself and see what's stored in the session. So you see that I have the BID. So that seems to be the ID that is being passed. Even though it says BID, if I go back to the actual vulnerability, and I go to the code flow, you can see it's ID. So I'm going to assume that that's maybe the basket ID, and I'll have to dig deeper in the code to actually analyze that. But for the sake of time, I'm going to go ahead and just try that. And what I'm going to try to do is manipulate this value to a different value and then refresh. And what you see is, I've exploited this. Now I can actually see other people's carts. So even though it says my basket, I can see what's in other people's baskets. Now this might not be the worst thing that can happen, but it gives me an idea of what people are buying that I shouldn't have access, and I can probably remove things from there. Let's see if I refresh. See, so I can so it's pretty malicious. I can delete stuff from people's baskets. Now let's see if I go to 3 and refresh. It's there, but now let's go back to 2. And refresh. And okay, so this is pretty bad actually. So I can manipulate people's baskets, and I can probably run a script that goes through this and pretty much always constantly unloads things from people's baskets. So I can do a denial of service error, and I can cost a lot of business or a lot of sales for this particular business because I can automatically drop anything that anyone adds through a script. So this is pretty bad. That I can perform this functionality and change people's carts and look at people's carts and manipulate that. So now we know that this vulnerability can actually be exploited. And if you want to learn more about how this particular exploit works, I'll have this link in the description, but there'll be kind of ideas here on the broken access control. And we know that it's because following this data, we know it's because we can pass in anything as the ID within the actual request that's being sent within the session. So we can dive deep into that and figure out why it's vulnerable. And if I just go here and I look at the actual code itself, then you can just see everything that's imported. We're importing the basket. And then here we're getting the request. We're getting the request ID, and we can look through the actual structure and see what the ID is. That's the only thing that was there. And you see BID here. So that's the thing that I can manipulate is the BID. So looking at this code, that's, as a hacker, I wouldn't have access to this code if it was closed source. But since, so that's why I examined this, and I examined the session itself and the storage in the session. So that way I can go ahead and try to manipulate this. Also through cookies, there's a bunch of different ways, but in this case, it was easy enough that it was just in the session data. That I can see what's in the cart because it's stored in this session. It's unencrypted and allows me to manipulate the value, and it's not sanitized, and it lets me pretty much put in anything that I want. So now what I'm going to do is I'm going to apply the fix, which is telling me to sanitize this particular item. So let's go ahead and apply a fix. So it wanted me based off of this. So it wanted me to use Mongo sanitize to sanitize the output. So what I'm going to do is let's go into so we're going to cancel it. So we know it's exploitable. So first thing what I'm going to do is it doesn't need triage anymore because it's exploitable. So we've triaged it and it's been confirmed. So this lets me set the status to confirmed, and then I can add a reason exploited via session bin ID or basket ID. So that way I can let other AppSec engineers or the people on the security team or administrators collaborate on this, and they can see the different inputs and see the reasoning of why it's been confirmed. But now, we want to go ahead and we want to be able to resolve this. So we want it to be fixed. So we're going to go and let's go into the actual code. All right, now let's go ahead and resolve this vulnerability. So the first thing I need to do is go ahead and add the Mongo sanitize library. So what I'm going to do is I'm just going to type in Mongo sanitize. And this is the NPM package for Mongo sanitize. I can look it over and see how it's used here, or I can just apply it how the file says. So I'll just go here. And first, what I'm going to do is I'm just going to create a new branch for this. So git checkout -b, and I'll call this fix basket issue. And then what I am going to do now is I will just do npm install Mongo sanitize. And this will take like about a minute or so. So we'll be back in a second. All right. So now that we've installed the MongoDB, we can do a git status, the MongoDB sanitize, and we can see that in package.json, the package for Mongo sanitize has been applied, and we can, fine tune this how we need. And then what we'll do is we'll go into the actual vulnerable file, which is then routes and basket. So this is the vulnerable file that we see over here. And what we're going to do is we're going to go ahead and import sanitize from MongoDB sanitize. So, and that's what's going to help us do the fix. And we're going to go ahead and sanitize the input. So we go back, and then what I'll do is I'll go ahead and just import sanitize from Mongo sanitize library that we've added. And then we need to sanitize this ID that's being used. But what I'm going to do is I'm just going to kind of break it down and remove all this validation stuff that we don't need for the hint to pop out and all these things. So just to simplify it, I'm going to do that. And what I'm going to do is just make it a little bit easier. So what we'll do is we'll just grab this line and we'll put it up here. See where the indentation, if I'm doing it right. Okay, so I'm going to do this, and I'm going to get the user request, and then what I'm going to do is I'm going to set the ID to the sanitize function, and then pass the user dot, I believe it was BID. And then it's good to have something to auto-populate for you, like use NeoVim or VS Code and look through the code. For this, I've done this example before, so I know exactly what my options are. But what I'm doing is I'm going to make sure that I get the authenticated user first from the request, and then from that user that I get, I'm going to get their appropriate bin ID, so that way I only have their bin ID, since that's what's actually being used and what I'm able to manipulate. And then I'm just going to delete this stuff here that I don't need because it's just for the hint. So I'll just delete these challenge utils. And then it seems like everything's matching. Okay. So then here now, when I send the request, I grab the user from the request and make sure that they're authenticated. And then what I do here is then I grab the ID, which is going to be the bin ID, and I'm going to sanitize that to make sure that there's no code that can be that can manipulate that. So these would be two changes that I need to do. Make sure that we actually get the user from the actual request itself. So instead of being able to pass any user or any bin ID and using that, I'm going to get the user itself from the request. And then the ID is just going to be the user's bin ID that I'm going to sanitize. So that way we prevent the actual exploit, because we're making sure that the user is grabbed directly from the request and is an authenticated request. And then from that user that's been authenticated, that's where we grab the bin ID. We don't allow the user to pass any bin ID that they want. And I'm also sanitizing this so that way there can't be any possibility of, weird data that I add and then I refresh and then I try to manipulate these things from there. So, and you can read more about that here. in the broken access control and the challenge solutions that kind of go over how to exploit that and what the fixes are, and how to resolve it. And these are different things that can be done with this exploit. So just learn more about it by following the OWASP resources. But now let's go ahead and try to see if this actually resolves our issue. So it goes through the basket, it parses the basket, and then it returns the items, and it grabs that basket based off the ID, which can only be derived by the user itself, and then sanitize it that way. So now what we're going to do is, once we have that, git branch, git status, and then now we're just going to rerun the command to build this, and we'll be right back and test this solution. So let's run podman build, and we will call this the same as the branch name, fix basket issue. All right, and we'll be back. And while these containers are being built, I just wanted to notice that these examples do show solutions that can help you to prevent more malicious actions. So if you saw Mongo sanitize, I could have applied it directly to this ID right here, and I could have prevented people from doing further malicious actions and adding certain scripts to become an admin or do worse things. But it didn't directly limit me from being able to just change the number and view people's items. It just prevented malicious things from occurring and me adding these kind of functions. So if you look at what Mongo Sanitize does, is it sanitizes inputs against query selector injection attacks. So it'll strip out any keys that start with this. So it prevents things that could have been worse, that someone could have injected data to that particular basket and done certain things. But it didn't prevent me from actually seeing other people's baskets and different things like that just by sanitizing it. So it's good to know your code and know, we know that this particular function is vulnerable here, but it's up to us to continuously try to exploit these things and use the data provided, because I could sanitize it and that limits me from some of the worst attacks, but it doesn't prevent me from seeing other people's data and things like that. That's why the code flow is so important, because it shows me where everything is going, and it shows me everything that I can do with it. So it shows me that this is where things can be manipulated and things can go here, but this lets me know, even though I know I should sanitize things, and that's what it tells me here, and validating different things, that is not enough. It's always important that not just to sanitize, but to really understand your code as well. And right here, sanitizing this is going to prevent more malicious actions and script injections and things like that from taking place, but it's not going to prevent you from adding whatever you want to the params. That's why I had to actually authenticate the user separately and then sanitize what is passed as the user. So that's what prevents this vulnerability. What I did is, and I have a merge request, so I can go over merge requests, fix basket. That was done for an earlier tutorial. But you can see here that by actually going to the user and actually authenticating the user first from the request, instead of just grabbing any data from the request, I'm going to authenticate the user first, and then I'm just going to sanitize what the user's bin ID is. So that way there's no way that a user can put something else and inject something that can, manipulate the data. I'm going to make sure that I first get an authenticated user and make sure that that user is authenticated from the request itself. And then the ID that the user has, I'm going to sanitize that and prevent any other data from being passed on there. So it's good to do the sanitization, but the real fix was just to authenticate the user first from the request. And once that user has been authenticated from the request, then I go ahead and I derive that ID from the user themselves. So that way it's not actually being passed. And the information gives us a clue as to, like, okay, we're passing data that shouldn't be passed, that's being used in this find one function. So pretty much what I did is I limited what's being passed. Sure, I can prevent like further injection, but I can't prevent people from actually changing it with this sanitize. So that's why it's important to know your code and go through the code paths and use the exploit data to try to continuously exploit it. and maybe I can prevent an exploit from someone injecting data and passing whatever they want to gather more resources, but I can't prevent them from adding a valid number like a 1 or a 2 or a 3 to change these things. So what I had to do is make sure that the data gets validated first from the request and not allow just an ID to be passed by the request. I actually, from the request itself, I make sure that I'm getting the authenticated user from that request, and then from that user that's been authenticated, then I'm driving the ID, and I'm getting that ID directly from there, and I'm sanitizing that just in case someone is able to actually inject that's going to be passed into this function. But this is the real code that results that. And then this is still building, so we'll wait a second. All right, the image has been successfully built, and now let's go ahead and run it. So I'll do the same podman run that I have here, my history. And I'm just going to change this to juice shop. And what did we call it? Let's do the branch name. So we called it fix basket issue. So fix basket issue. And now we're running that. Let's open an incognito window. New private window. 127.0.0.1. 3000. All right, and now let's just create a new account because I removed all the cookies and everything. So now we'll just do this. fern@fern.com. And then we'll do password 1. Okay. Register. Password 1. Login. All right, and now let's open up our developer tools. So we'll go here and we'll go to developer tools. We're here in our session storage. Let's go to our basket. And now let's change this bin ID to a 1. Refresh, and we can see that there is nothing happening once I do this. I can go back. I can add a bunch of stuff to my cart. And you can see that I can add a bunch of stuff only when I have my BID value as 6, because that's my user ID. And I can manipulate that. But if I try to go to any other value, you can see that nothing changes. So I can only add stuff on 3, and I can't see anyone else's data or manipulate anyone else's data. So that's how we've resolved the vulnerability. And if I go back to here, now I can go ahead and I can just go to my repository. I can go to the vulnerability page, so secure vulnerability report. I'll sort by the ones that were confirmed. And now I can go ahead and resolve this. After I've pushed up a merge request and merged it, I can go ahead and resolve this and then see if there's anything newly detected from there. But as far as we know, we have remediated this vulnerability and it no longer exists, and we can track this. Once we've created a merge request and merged it, we can just resolve this, and then it's been resolved. And then we can add here a link to the merge request. So yeah, so that's the tutorial, and I hope you enjoyed this session. Feel free to look at the links in the description and give GitLab a free trial. So if you go to just GitLab Ultimate Trial, then you can try Ultimate for 30 days in SaaS, or you can self-manage it as well. And then you can also apply for the GitLab Duo trial. So there's also GitLab Duo. And you can go here and then you can get started with the free trial for Duo as well. And there's a bunch of other AI-based tools as well. And you can learn more about that with the links in the description. But thank you for following along and hope you enjoyed.